Yeah, we did not actually progress much from our last stage. Let's just show what we had the last time. So I know there is somebody else like Rostami who actually created the Azure ML stuff, but he was doing using AutoML and I'm doing just the regular stuff. Okay, so are you able to hear me?
If you can speak louder, are you guys able to hear him properly?
Uh, it's difficult to hear. Means the sound is pretty
Faint,
low.
right? Yes. If you can speak a little louder, that will be helpful.
Yeah, due to the recent like Rogers outage, the networks have become much worse. Okay, hold on. Okay, the screen sharing is disabled.
Yes, sorry. Yes, it's okay. Now you can.
Okay. Okay. So hello everyone. Before we begin, this is team 3, and we are actually implementing the this challenge or a part of it using Azure technology. So we are going to use Azure machine learning, and we are going to create everything on the cloud. The advantage of this is that it is all cloud native to begin with. It is very production friendly, and you can get support from Microsoft regarding its best products, right? So most of the modules, the models, the hyperparameter tuning or whatever, these are implemented by Azure. So you have the best and most optimized version of the code, right? Suppose you are making some memory issues when you are writing manual programs, those things are not going to happen here too much. You can write your own custom coding, but that still will not be as much as if you're writing the whole thing from scratch. Okay, so we will begin by using the baseline model directory. And in this baseline model directory, we have things like imputation, we have different artifacts, and we have a baseline model, right? So basically, this consists of two parts. One is the imputation, and then, or rather, imputation transformation pipeline, and the other is the baseline model pipeline, right? And our raw data is here, so we have original raw data or CSV. This is where we'll begin. We will split this data first into two parts. One is the train, another is the test. And then the train one we will split into two parts, which is train and then validation. Right. Mm, great. So the implementation that we are going to do is kind of to show how you can quickly do something like this or implement something like this in Azure. It's not like going for the best accuracy, but the methodology and the usage of the new tools, new ecosystems is our target here. Okay, so with that, let's go into the actual Azure services. We have uh, we have things like machine learning, we have blob storages, and we have subscriptions. Okay, the way Azure works is that you have a billing account, you have a subscription. Within this subscription, of course, your costs will be calculated, right? Within the subscription, your costs will be calculated based on your resource usage. And if you go to view resources, whatever resources you have, you can see all the resources that are being used by this subscription, right? Here we have, for example, a container registry. Container registry is to build Docker images. This is required to make it a immutable environment. So the concept of an immutable environment is that when you are launching something on production, your environment cannot change, right? Suppose you are using shell scripts, then that is mutable because somebody can go and change the shell script. But a Docker image or container registry images, these are immutable and you cannot change the environment after you have launched in production. Okay. This one is the main machine learning component. This is actually an umbrella workspace under which all other components work. So if I go inside here, you can see that this is just overview, right? You have a subscription here. You have resource group information here. You have a studio web URL here, which we will go inside. And then you have other login stuff here. Notice that there is a MLflow tracking URI, which we haven't used here, but it is an incredibly useful thing for tracking and monitoring and all those things, right? Okay, the only other thing we will see before going into the actual machine learning component is the storage account. So this storage account is actually a object storage. You can either keep objects in the first things in the form of objects, or you can keep things in files, right? For example, I have kept something like this in a file. So train data and test data, right? We will see how we can produce artifacts in the file through a pipeline, right? But know that whatever is going on in the machine learning workspace, you will have a few artifacts in the blob storage, right? In the storage account. Most of them are either stored as codes or as zip files, packages inside these auto-created accounts. Okay. Okay. So if you are not able to find something, just go inside here. You can find it. Okay. Now let's go into the machine learning component. Now in the machine learning component, what we are going to do is launch the studio. And in the studio, we are going to see that how you can create a pipeline, right? Okay, so this is the main machine learning component, the kind of a workhorse where you're going to put in data, create models, create endpoints for those models, and a host of other services. Okay, there are three main ways in which this can be done. The first way is that you can create your own manual thing, right? Okay, so you can go to notebooks and you can open up a notebook. You can do all your data engineering stuff here, create models, and then deploy them on production. That is number one way. Okay, that is completely manual, and that is basically a replica of what we have done here. Here we have created artifacts, we have created notebook files, we can create Python files that will run and do these similar things. So this is all manual. Similarly, here you have everything that is manual. Everything you do will be manual. The second way to do Azure machine learning is automated ML. So auto ML means you just give the data file and everything will be generated for you. You just give it a few options like what kind of model, what is the target variable, and then all the artifacts will be generated for you. This is quite good if you are beginning into machine learning and if you really have good data. If you have to do very complex feature engineering, this is not the best way to do it. Plus, there might be a few small features missing here and there that you might need for customization. Right. The third way to do Azure machine learning is kind of an in between the manual way and the completely automated way. And this is through something called a designer methodology. Right. So if you go here, you can create a design, and using the design, Azure will generate code that will do stuff. So let's go to the design that we made for this project. The designer. Okay. So this is the first design that we made for this project. This design tells us that basically take the original data, the original raw data, and execute some Python script on it, create some features out of it, and then you have to split the data into training and test. Okay. After you split the data, you can export the data to say blob storage. Here we are exporting to file storage, right? And this export option is what you see when you go to the blob storage. So it will save something called xtrain.csv. Similarly, export data will save the xtext.csv. These files can be read from the Azure Machine Learning later on. Okay. So the main focus of this script is to execute the Python script. What Python script is it executing? Basically, the Python script that is executing is just copied code from this module. So we have the baseline model repo, and we have a whole bunch of code here. All the things that are done here, for example, data cleaning and reducing nulls, visualizing null columns or descriptive statistics. Then if you go, you have to fix some of the columns, delete the year 10 state factor. So making these age variables, these things we are doing inside the Azure script, right? So this is like a mixture of manual plus automated. Are you following me, everybody?
Yes, Roy.
Okay. Okay, so this is a mixture of manual and automatic mode. You take the script that you have put in the notebook and you put it inside the execute Python script. The execute Python script takes in two data frames, data frame 1 and data frame 2. But here we are only going to take one data frame. You can, if you want, take an optional data frame. Using the data frame 1, first of all, notice that this code is not written by us. We have not written any of this code. This is automatically generated by Azure. So if you are worrying what will be the signature of my function be, what are the parameters, in what order, what libraries I need to import, you don't need to do anything of that. You just go ahead and fill up a bit of the part here to basically create whatever columns you need, right? For example, here we are creating these facility type columns. Here we are creating merging into quarters and creating some quarter variables. And then we are dropping a whole bunch of columns. So all these things we are not leaving up to AutoML to take care of. Remember, if we do complete AutoML, you have very little control on what variables will be selected, what kind of features you want the algorithm to give importance on. So you have absolutely zero control. Here, what you are doing, you are helping the model to narrow down and use less variables, use better features with which will explain more variance, and then just return that data frame. Okay. Do your thing that you did in the notebook and return the data frame. Once you return the data frame, you will split the data into train and test. So this test we can later use for testing purposes as a holdout set or whatever. The next part of the pipeline will be made using the training data that we export.
Excuse me, Roy. I'm a little confused here. So
Yes.
this is, you said there is one manual method and there is one automated method, right? So we are
Yes.
talking about the automated method here, right?
No, we are talking about the semi-automated. So this is
Semi.
not.
So you have three.
Yes, you have three. You have
Okay,
three.
okay,
So one is
okay.
completely manual, another is completely automated, another is a semi-automated, where you are also able to contribute to the code. Okay.
So when you are doing a complete manual, you are just using the storage part, right? You're not doing anything else. You're
Yeah,
not using other features.
yes. You are
Okay,
not
okay. Got it,
pipeline.
got it.
You are
Okay,
just
thank you. Yeah, thank you.
okay. So this piece of the pipeline is just used to create these features, right? Just basic cleaning stuff, transformation of variables, right? Now, the next part of this, which will be using the train data, will use another version of the energy data. Remember, the energy data is exactly the raw data, see, original raw data. But after this pipeline has been processed, we are not going to use the raw data. What we are going to do, we are going to use the processed version. So we have something called energy processed, which is nothing but the training data that we got after splitting the previous pipeline. Okay. So this is the very same data. This has no extra things other than these variables. So you have these numeric variables that have been created, right? Okay, now this one is a much longer pipeline. This pipeline we will use when we are doing inferencing, right? The first thing we do is clip values. Clip values is an outlier detection mechanism where you are using different mechanisms like either normal distribution clipping, or you just clip the peaks, right? You can clip sub peaks, you can clip peaks answer. This is based on the different options that are there to clip a data to get outliers. For example, you can use the interquartile range, you can use the normal distribution. Whichever way you use, you are going to apply those outlier detection techniques on the numeric variables only. So here I have to go and select all the numeric variables individually. So I click on edit column, I go to the column name. So you can do by name or with rules, right? I went to by name and then selected all the individual columns that I need for this operation. The true flag means that you have to replace the original columns, right? And the indicator column false means that you will not make a separate column that shows which ones are the outliers or something, right? Okay. The next step is clean missing data. Remember that in the notebook version, we are using something called simple imputer, right? And in this simple imputer, we are just using a combination of simple imputer and we're using the most frequent simple imputer. This is like the mode, and we are using scaling as standard scaler, right? These two operations are being operated on all the numeric data. And this is an operation that is operated on the categorical data. We will come to this. So let's first look at the numeric data. Here again, I have chosen all the numeric columns, but I have not chosen the target variable. Remember, you cannot put the target variable in this thing, right? It is of no use practically. So if you do that, it defeats the purpose. So I remove the target variable and put in all the other numeric input variables. I replaced with the mode. These are the other things you can replace with, but I replaced with the mode because I saw that this is the most frequent thing here. And then after that, I am basically again replacing the whole columns. Right? Columns with all. If there's a column with all missing values, there are no values in the column, it will simply remove the column. Right? Okay.
Can you please go back and tell me? I'm confused about this missing and sorry, minimum and maximum missing value ratio.
Okay.
Why it is 0 and 1?
These two, see what it says. Clean only column with missing value ratio above the specified value. So only if the number of missing values are more than 0%, then you apply any imputation on the column. If you go to the notebook, this one will flatly apply the simple imputer on all the numeric columns, right? Whether or not has doesn't matter how many missing values it has. So this is like a flat operation. This one here will actually go and check whether there is how much missing percentage is there in the data. If it is less than, if it is greater than 0, I can even make this 5, right? So if it is more than 5%, then you do anything. Otherwise, you don't do anything. Right?
Okay.
Similarly, you have to see what is the maximum missing value. Clean only columns with missing value ratio below a specified value. Right? If it is missing less than 1%, then you apply that. If there is too much missing, then maybe you want to do something else. Right? So
Thank
this
you.
is an option. Another is replace with mode. So we are replacing with the most frequent value, right? Strategy. And finally, we are not generating indicator columns, meaning we are not generating a separate column that says these values are missing, right? Okay.
Thank you.
Another thing I should tell you is that these output settings, try to click on the regenerate output, right? This is because if you are running the pipeline multiple times, it will use some cached value and it might give you wrong results, right? So I try to click on the regenerate output every time I run the pipeline. Okay. So the next activity is the edit metadata. Why do we need this? Because remember, in the notebook, you have something called categorical transformer, right? Categorical transformer only works on categorical variables, categorical columns like these. However, in the actual data frame, these are just simply string columns. So these are not specifically of categorical data type. Okay. This is what we do here. We go and edit the metadata. We select which are the categorical columns. We just convert them to categorical. Either we can leave them unchanged or we can convert them to categorical. And then you have to just, yeah, you don't do anything else, just click on regenerate output and convert them to categorical. The reason we did this so we can do the next step, that is convert to indicator values. Again, give the same columns, the categorical columns, and this time I am overwriting the categorical column, which means the actual year factor column will be replaced by the columns that are generated from this activity, right? So it will be appended to that. If you want to see how that looks, let me go to the jobs. Let me go to this one and see what has run, right? Sorry, not this one. Go to training and go here. Here you can see, if I go and preview the data, results data set, you will see that instead of the actual categorical columns, it is generating the ones with the factors. So you have year factor 6, and then you have state factor, state 11, state 1, 2, 3, 4. So it has taken away, removed the old column and replaced it with the indicator columns, right? These are the indicator columns, 1, 0, 1 columns. So you have building class, commercial, building, residential, facility type. So all the categorical columns have been converted to indicator columns and simply appended with the data set, right? This is equivalent to doing 1-hot encoding. So what we are doing here, 1-hot encoding, this is the same equivalent to that. And finally, this column transformer is actually creating a pipeline that will do one after the other. In our case, our procedure is already a pipeline, right? This already looks pretty much like a pipeline. And that is why this is more production friendly. So we take the pipeline, and the next step we do is we do a normalize. Again, we do a normalize on the input numerical features only. We use the z-score method. You can use all these other methods to normalize the data. But since we are using the standard scaler here, I just use the default z-score method, right? You can do logistic normalization and everything. After that, we are applying a math operation. That is, this is the first time we are actually applying something on the target variable. So we take the target variable, we do a log on the target variable, right? Instead of log, we can do a whole bunch of other functions. But I saw somewhere here that there is a log being applied on the target variable. Somewhere I saw in one of these notebooks. So that is why I applied the log here. During inference, that means when we get result, the model will actually output the logarithm of this number, right? So to get the actual result that we will need, we will have to do an e to the power x of this later on if we are doing inference. And finally, after all that data preparation and categorical preparation, I create a model activity. I split the data. So this is split into training and validation. The training data set I put into a model activity, and we are using the XGB, or the boosted decision tree regression, right? If you open this activity, you will see that there are lots of hyperparameters. And this is exactly the same thing with the XGB version that you use in scikit-learn, right? All the same options are there. You train the model, and then I use the validation to score the model, and finally to evaluate the model, right? So how does the model evaluation look like? If I go here and we preview the data in the evaluation, we will see that we are getting the exact metrics that we get from the notebooks, from all the methods that we have used previously. We are getting things like mean absolute error, roots mean square error, relative absolute error, and then coefficient of determination, right? These results are kind of similar to what we have got previously. So RMSE of 0.72, mean absolute error of 0.44, all these things. These can be improved with more sophisticated methods, but I wanted to show how it looks like so that you get a analogy and a parallelism between this notebook, what it is doing, and what we are doing on the Azure ML, right? At no point of time should you be confused as to what am I going to do. If you are already comfortable with notebooks, this shouldn't be too difficult for you. You'll just have to do a bit of drag and drop. The last thing that I want to tell is that this is a training flow, right? But this will not be used for inference. Once you have run this process successfully, you can click on the inference pipeline to create an inference pipeline. How does the inference pipeline look? Let's see how the inference pipeline looks. So the inference pipeline will actually have some extra stuff from the previous flow and from the new stuff. So to do inference, you need new data, right? Where are you going to get that new data? You're going to put it in the web service input. These processed artifacts are coming from the trained procedure. So you have all the transformations that are saved, and these transformations will be applied on the new data, right? And then finally, we have a web service output where you can get the output if you are looking to create inference. Now, this is a real-time inference. That is why you see web service input. If you created a batch inference, you will see something else. It will basically take the input from the blob store only, right? This is how you can create training pipelines and inference pipelines for production on Azure ML, right? Please feel free to ask me any question. Hello?
Any questions, anyone?
So the production is here also they are using something like ML ops for the production, putting the model to production.
Yes, yes. If you go to the studio and you go to, suppose, say, jobs, see, each of these jobs are being tracked. This is what MLOps does. It tracks every time you make a change to the model, to the data. It tracks all, it logs all the outputs and inputs from those experiments, right? And each of them is an experiment. See, this is an experiment, right? And then you can have failed experiments. These are all MLOps procedures. So it tracks each and every experiment. It does not lose any data. And from these jobs, you can even extract the registered model. So suppose this pipeline ran and this model ran, you can extract the model that is used in this particular pipeline, right? That is what the beauty of MLOps is. Each and every experiment you do, you can use those artifacts later on to do things in your future pipelines. Okay, you can extract every piece of information from these previous experiments and use them in your new ones.
Okay, and then if there is any glitch there, that is taken care of by the ML engineers, right?
Yes, yes, yes. If
Okay,
there's
okay.
a problem, anything that is not working, you have to find out, tweak a little using the engineer skills and technology.
Okay, thank you.
Just remember there are two pieces, two totally different pieces, training and inference, right? Whatever you do in training exactly will not be used in inference. It will be a little different. So always be careful about the inference pipeline. For example, here you don't need the math operation. You do not need to do a logarithm of the target variable because you do not have the target variable as input, right? So you can pretty much remove this and just connect those data sets to here, right? So those small things you have to look for. Otherwise, this is very easy. You just open up a subscription, create a bunch of data, go to data, and then create this data, right? If you go to data, you will see that I have multiple versions. See, latest version is 2. So version 1 was where I had the ID. And in version 2, I just change the metadata. If you want, you can even take a new version and upload a new version of the file, right? So you can do browse files and upload from local file. This is just what I did. So I took the blob store and then I browsed from files, and then I took the original raw text. Okay. And then I just chose what are the file, what are the columns, and what will be the data types, and I started my process. Right. See, it will automatically parse it out and give you all the output. Very easy. If you have some very not so, if you have a delimiter that is not in here, you just put that delimiter as a custom delimiter, right? Or you can change the delimiter to one of here. Generally, one of here is sufficient enough. Yeah, that's it. That's all I had for today.
Imran, you're on mute.
Thank you. Any questions, anyone? Good demonstration, Roy. I enjoyed it. One quick question. You were mentioning about one is manual, the other is auto manual, or auto ML. The third one is, I think they call it designer or something, like the semi-auto, autonomous. Indy, have you tried an auto ML one, like you just dump in your just our train data like raw form and then see how what it pops out?
Yes, I have tried that. That is also pretty nice, but that is too automated. Like everything will happen so fast, you will not, like, it will blaze by your brain very fast. So there is no learning there inside AutoML. The learning perspective is not too much there. You can do stuff if you want to quickly do and implement,
Like
but
quick and
the
dirty.
whole journey, the following each and every activity, why we are doing it, how it will affect the pipeline, those things we cannot learn if we are doing total AutoML.
That's understandable. And yes. Also,
I have a question.
Yes, please.
What are the scenarios you would actually use Python instead of AutoML? So we have seen the advantages of AutoML over using the traditional methods.
Yes.
What are the scenarios, or what would be the advantages using the traditional methods instead of AutoML or any other tool like that?
Generally, I will tell you, if you have tabular data, you can use AutoML, okay? But if you are doing deep learning, for example, X-rays and remote sensing and object detection, those things you cannot do from AutoML. Although there is an option called deep learning, but it's not that sophisticated to capture all the variances inside a deep learning project. So if you are doing deep learning, please do the notebook thing. It will be of much more useful, right? AutoML is where you have tabular data and you are predicting a regressor or a classification problem. That is, AutoML is good for that.
Okay, thank you.
Any other questions, anyone? Also, I'm also curious, in our pool of candidates, do we have somebody who is also at least using AWS in industry?
Yeah, that would be interesting too.
All right, I'm just curious. Or anyone who has somewhat exposure to AWS.
Because ultimately, when you're doing the job in a company, they are most probably going to be using one of the three clouds, right?
Yes.
So it's good to have exposure in that.
Right. Okay. So nobody even have any beginner or intermediate level as well.
I just began with the AWS machine learning.
Okay, like very early inception stages, early stages.
Yeah, initial. So there is one website called Per Scholars. I can put it on Slack. That website is giving cloud training free of cost in a particular. So when you go to that website, you can choose your where you live. So based on that, either they have online or on campus. So if you are not working or something 9 to 5, you can go there and get a hands-on. Otherwise, they'll do it online. I can share that on Slack.
Yes,
So I'm
please.
taking it from there, and it's really nice.
You
I
do it
think
for
that's
free?
yeah, it's for free. Like it is like I think it's the post-pandemic requirement, or I do not know what, but it's for free. You can get those inbuilt skills that you need in cloud or other technologies to be job ready.
Nice. Yeah, that will be helpful for everyone if you can please share on Slack.
Yeah,
Thanks for sharing
so
it.
yeah, I live in St. Louis and they have an on-campus here. So even if you do not know whether it's available in the city you live in, you can put the nearby one. So based on that, they will send you an email saying, looks like you live here based on your zip code, and there is one there, so go there. So they'll send you that also. And they will also schedule a call one-on-one with you to see what you actually know, what you actually want to know, and blah, blah stuff.
Interesting. What does it call again?
firstscholars.org. I will put it.
Yeah, that will be
just
helpful. The firstscholars.org.
yeah, just a moment. Let me put it here.
Please put on Slack. That will be most helpful. So at least
Yeah,
people
I'll
can-
put it on Slack. Here it might get lost in the Slack.
Which
It will be
channel?
there.
Which channel on Slack? It's fine.
Announcement.
Yeah,
I'll
announcement.
put it in announcement so
Yes.
everyone looks at that, right?
Exactly. Okay, that's good. Sure.
Also, if you go to Amazon has the AWS learning, in which it's really nice. They have the videos and they have everything. You'll get one by one step to step guidance.
Yeah,
I
all
can
of them
put
actually,
that.
Azure, Google Cloud, Amazon, they all have on their
Yeah,
websites.
all of them
they
have.
Of course,
Yeah, all of them have. But one difference is, I think, for Azure, you have to follow the document, and it also has the videos. But I feel what AWS is having is much more clear for a beginner. I feel so.
Yes.
And I already had a chance to use AWS once, so I'm going with that. For Azure, I've used the ETL things. I feel that is much easier. I've not tried the ML for that. I'll put both of these in the Slack after the meeting is done.
Okay, good. Thanks for sharing, Sunita.
Yeah.
I finished one of these specializations. Also, I would say on an intermediate level, but I was hoping if I know some, if we have anybody, some working professional who was applying AWS, I was wanting to talk to them. Hopefully that could have been better discussion, but that's okay. Idea is ours. We are still have covered pretty nicely in Azure. And my personal goal is also to give somewhat the participants exposure to AWS as well. So then at least they get a holistic picture, and ideally just show them end-to-end ML pipeline. So that would be great. That's what I'm personally shooting for. So hopefully next week. Okay, that's enough for today. One thing I want to ask all of you to please like or follow our LinkedIn page. If you don't have that link, let me share it very quick as well. And, otherwise, apart from that, if anybody have any questions, feel free to ask. Otherwise, we're gonna wrap up. I just posted this link. Those who haven't followed, please would be great. Support your team, support your this group. And otherwise, if no questions, so then we will have a next meeting on Wednesday in which team 4 will be presenting. And yes. All right. Any other questions? Otherwise, we are wrapping up now.
Yeah, I'm good.
Okay, guys. Have a good weekend.
You too. Have a good one. Bye-bye.
Thank you. You too. All of you. Bye-bye.
Thank you. Bye. Hey Imran, hey Salman. Good morning.
Hi, Roy. How you doing? Hi, Imran.
Hey, good. Just woke up actually.
Morning, everyone.
Good morning.
Morning.
Good morning.
How's it going, guys? While we wait for, well, I guess I should wait for a minute to let other participants.
Imran, any update on the data quest?
Yes, so I'm gonna cover that just a second.
Okay. Yes, sure.
I think it's already 9:04, so let me start with my agenda since it's recorded, so we are good. First, I have a first announcement is I want to ask you guys. As of now, I noticed there are only half of the active participants have responded to the survey. So I request the other half to please respond to the survey. So at least hopefully it will help us to tailor our strategy if needed. So please do so in a timely manner. We shared on last Wednesday. So try to get it done by today, so it will help us a lot. Thanks. Second is, yes, my question to part one participants. Did you guys get the access of our data quest? No, not yet. So what's happening? Can you guys tell me the challenges? Although I messaged the Omrina guys, but I want to know what's happening on your end.
So I got the coupon, but when I put my coupon in, it processes the coupon and it does nothing. Means then it kind of like get me to the again paid plans. So
oh, okay.
it does not apply the coupon technically.
Same for me.
Same for you?
Yeah.
Okay, I assume then same for all of you. Well, so based on some of the private messages I got, I sent the query and they told me that they are working on backend. They said it's weird, it never happened before. So they said they will get back to me and then pretty much to us. So I'll let you guys know as soon as I find out. So that's the data. And
Unless there is another way to access the coupon, because the link that they shared in the email is not the right link to access.
So means I went on to the data quest main website. I created my own account.
Okay.
And then I kind of like went on to means premium, and there you give the option for so I tried that as well, and it did not work.
Yeah, so I also tried the same way. I'm saying the link that they shared saying there is a method to access the plan, unless there is another method to access it, which they have not given. The obvious method doesn't seem to be working.
Okay, so yeah, same thing. I guess I got in through a private message. I shared them with them, and she said that time it's weird. She said I'll get back to you. So
yeah, even few people like Manasa, Timur, they have shared the same problem with me.
So I guess all of us are having a same problem.
Yeah.
That's, I guess we are on the same page. Yeah, I just checked my messages. I'm not seeing a response. So I guess we gotta wait a little. So hopefully I should have an update by early next week.
So I said Imran,
I'm sorry, carry on.
Please.
No problem. Please carry on.
No, so regarding the same, so I was just saying that there were some emails given in the same link. So I mailed them also, but there is no response from them.
I mean, yeah, I'm assuming there's some technical issues, so give them some time. But I'm pretty sure access will be given. So it's just a little bit of patience needed on our end, I guess. Yes, Sunita, you were saying something?
Yeah, is this access for everyone? Because I didn't receive any email.
So that particular announcement was for part one participant. For part two, you guys, whoever will stay active, they will get a data campus access.
Okay.
And Salman and Komal are talking about data quest.
Right? Okay, thank you.
Okay, I think we should get started. Today there's, I know, a lot we have in Salman's agenda, so I guess, and I know Roy is supposed to cover. So maybe I think let's restrict to Salman. I have some stuff, but I think that will be more wise to cover next week, I guess. And I also request before you guys start, maybe restrict to 45 minutes and less per lead, because we have work-life balance also to maintain. Okay, I've given you access, Salman, so you can
Sounds good. Okay, so I'm doing something a bit different than what Rich's team has not done yet. So because the whole point of dividing into several different teams is kind of like look at different approaches. So since whatever they have applied, I try to do something different so that I can bring something new to the table. Okay, so what I did is basically there are we know that for machine learning models there are several different learning methods. One of them is ensemble learning. So decision trees are decision trees are used in majority of the bagging and boosting, random forest and gradient boosting methods, right? So what those ensemble method does is basically they use multiple of simple Bayes decision trees, and based on that they aggregate the results technically in different ways. That is in the background that is happening in random forest and gradient boosting. There you can make stack using different strategies as well. For example, I made a template for baseline models. So most of you are using it. So in this model, what is the point? Why exactly I ended up making 12 models? What is the point of doing that? Because I wanted to see which model is giving me some sort of good results. For example, if you see what I did is I tried different model types. So linear regression, lasso, ridge, and elastic net, they belong to one family. Linear, they just predict a linear line. Nearest neighbor is a totally different class. The decision tree is just standalone, one single individual decision tree, but tree regressors and random forest are bagging methods. So bagging and boosting are a bit different. Bagging is basically hundreds of decision trees are used, and then you kind of like get the output from them. But boosting, the gradient boosting, light GBM, XGB, what these boosting algorithm does is basically they take care of the result of the previous model. So the previous model affects the results of the next one. Bagging method does not do that. Boosting method does that. So that is the small difference between them. So that is the reason why kind of like boosting methods kind of like excel in a lot of different situations. You can make your own stack as well. So that is where three different new techniques or ensemble techniques comes into play. They are simply generally you can call them stacking, but they are different ways you can stack different models. For example, random forest is using decision trees as its base model. But what if I want to combine models from several different techniques like KNN, support vector machines, linear regression, and random forest, bagging and boosting, random forest and gradient boosting. Let's say I'm using 5 different categories of models. And what if I combine the results of all of them up? That can give me better results in some situations. In some situations, yes, it will not give me better results. I would have to do some tweaking and hyperparameter tuning and things like that. But the idea is benefits of one model covers the drawbacks of the other model. So if you use several different model types this way, it can improve your results. And that is what has been seen in majority of the combination. And this is what I tried. So one of the simple basic one is the voting. So we kind of like got results of 12 models, right? So I will pick the best out of these 12, let's say from every family, linear regression family, K nearest neighbor family, then boost bagging family and boosting family. Right now, I did not try support vector machine, but if you look at the template Rich provided, he has support vector machine as well. So I can do support vector machine as well. So 5 different families of models, I can run them and I can get the results out of it. Instead of using them individually, what I can do is I can average out the results of all 5 models. That is what we call voting ensemble. So voting ensemble, what it does is basically, I have kind of like implemented a small version of it. sklearn provide a simple basic implementation of it. They have a voting regressor in it. What it does is basically over here, I'm just training 3 models just for showing purposes, but you can add as many models over here as you want. But this template I would be providing you, I'm still tweaking it. So I'm still kind of like optimizing it. The hyperparameter tuning part, I have not optimized it, but the simple basic implementation is there. What I'm doing is I call the data, and then what I'm doing is I'm creating a list of models. ridge, k nearest neighbor, decision tree, because they run really fast. So I wanted to kind of like just try them because right now I'm just tweaking, so I don't want to waste a lot of time in training. So, and then I'm just calling voting regressor. What voting regressor is doing, it is basically training these models in the background, then getting the results, the prediction.predict method from all those three models. Whatever results I'm getting, it is adding all those three results and then average, dividing it by 3. So simply it is taking the average and it is giving you an average result. So that is what it is doing. Since I just applied it on the baseline model and the baseline pipeline, yes, it is not giving me a good result, but this is the implementation, which means now what I'm doing is I'm just making templates right now. The thing here is playing with the feature selection method, playing with the data analysis, outlier detection, or so many different things. Last time Michael said that he tried different strategies and he improved the results. And I think I suggested that if he can try the outlier, because in the pipelines we did not try outlier detection. Means we did not implement it outlier detection. Yes, we did in part 1 outlier detection and everything, but in these pipelines, I tried to keep them as simple as possible and left it for you to explore all the different avenues. So outlier detection can do a lot of different things. For example, when I was looking at my EDA, I figured out one important thing, that if you look at year number 6, year factor number 6, out of 76,000 data, 50,000 data is from year 6, which means that is means way more than means bigger than 50%, means 50% and 76%. If you drop all the missing values or things like that, you will end up with predominantly year 6. So what I can do is, since we are not doing the time series part, I can drop all the remaining years whatsoever, because what is happening, a lot of buildings are repeated in several different years, which means if I drop all the remaining years, that can also give me a complete no duplication whatsoever in my data. Right now we have duplication. So then we will have no duplication whatsoever, and we would have still 50,000 data points. So we can try that as well. So many different things you can do, but these are the templates which will help you kind of like optimize different things. So voting method is one of it. Now, what voting is doing is, for example, here I'm training 3 models, right? So what it is doing is it is giving 33% weightage to ridge, 33% weightage to neighbor, nearest neighbor, and 33% weightage to decision tree. I don't know whether decision tree is playing a big role or small role as compared to the others. I don't know that, right? I should be able to optimize the percentage I'm assigning to each individual stack that I'm making here, right? Each individual model. That is where the second technique comes into play. And we call this stacking ensemble. And what it does is basically, so sklearn has a simple basic implementation of it just like this. What you do is, in this whole thing, instead of voting regressor, you can just change it to stacking regressor, and that's it. So when you do the stacking regressor, what it does is basically it figures out. So in the background, it is doing something, means I want to quickly show it to you. So it is doing something like this. So we have 3 different models, y equals to coefficients, and then x1 plus coefficient. Since we have 3, I will just do it. And coefficient.
Sarwan, are you writing something or showing something?
My bad. Yes, I am right. I will
sorry.
Yes, I think you should be able to see. So y equals this or this, and then we end up with the bias. So this coefficient in voting regressor, I'm assigning equal weightage to everyone. But what I can do is I can make a stacking regressor. What stacking regressor does is basically it uses 2 stages. The first stage is it train the individual 3 models. Then it gets the results from those 3 models. And then what it does is basically then the results of those models get input into another model, which I would be using as a simple basic linear regression, for example. Because this is an equation of a linear regression. So what linear regression does is basically figures out what are the values of these coefficients. In this scenario, this x1 is the output of model number 1. This x2 is the output of model number 2. This x3 is the output of model number 3. when I'm running the model, training it on the results of the previous models, then it will kind of like figure out these coefficients. That means what is the weightage of my linear regression model, what is the weightage of decision tree, and what is the weightage of the support vector machine or whatever model I used. So that is another way to do it. So this is what we call simple stacking.
So each model you're treating it as a feature here, right?
Absolutely. Yes. Yes. So technically, you can say I'm creating or generating features by training the models initially. The predictions are my technically features, and I'm using those as the input to the next model. Yeah. So that is another way to do it. Now, there comes the third thing, and that third thing is called blending. So this is stacking. And blending, there is a very slight difference. They are technically same. The only difference means the difference between bagging and boosting is a very small difference. The same thing happens with the stacking and blending. What blending does is exactly the same thing, but the only thing is on what data set it predicts the result. And sklearn does not provide an implementation of blending right now. There are few other libraries. I was exploring few other libraries, but I don't see the point of using those libraries because implementation is pretty straightforward. I will be making a template for it, and I would be providing the template for the blending. Right now, I'm working on it. It is something I'm still working on it. So it is kind of like would confuse you if I show you. What it does is basically, instead of using the stacking regressor from sklearn, I would be training the models individually, which I have already done. After training the model, I will be saving them in a separate list. I will be creating a data frame, let's say. And then I would be creating another model, let's say linear regression or ridge or lasso, whatever. And then I would be inputting the results of the previous models into that model. And then I will predict it based on the test set. So what stacking regressor does is it basically evaluates the result on the train test. So it does not. So you can say that it does not do on holdout set. So remember when we do train test split or something, so we are holding out the test set technically. So that is the holdout test. So what stacking regressor does is basically it does not allow you to predict it on a it or train everything on the scene. So technically you have already seen the data on which you are predicting the results and everything. So that's why stacking kind of like lacks a little bit as compared to the blending. So blending is basically checking it on the unseen data, you can say, even though it is unseen data because we are using k-fold cross-validation or something, but still there is a slight difference between them. So implementation is a bit different. Otherwise, they are pretty much same. So these are the three things I'm implementing. Initially, I said I would be implementing neural networks, but last time I think Rich's team Manasa already has implemented it. So I didn't see the point of kind of like discussing it today. So those things, yes, I'm also trying those things, but these are the things which are a bit different. And if you want to try, I will be uploading these templates. So I would recommend you at least play with them, at least try to go through them. And I will be sharing a link. Just 1 minute. I would be sharing a link. So I have been using the same blog, Machine Learning Mastery, right, from Jason Brownlee. He has the implementation of all those three in a very detailed manner for classification and for regression. So I would recommend go check out his blog as well. So he gives you step-by-step implementation, and I'm kind of like sticking to his blog. I'm kind of like implementing, changing things based on our data set and based on our things, but I'm pretty much sticking to the same because the logic and technique are technically same. So why bother writing a different code or different line when everything is already provided? So I'm not copy pasting, I'm changing, adjusting it based on our model, based on what models are giving me good results. He's just giving you a general, he's creating a regression model out of thin air, and we are using it a real life problem. That means there are some differences. So we need to tweak few things around. The parameter optimization thing is something which I am working on my own. He does not provide that, but I would be providing that. So so far the results are not good because I'm still applying on the baseline data pipeline. So I haven't applied them on any other pipeline. I would start doing that, and now in the final presentation, you would see a big jump in the improvement on the score. So I'm sure that it would improve the score, because there are a lot of data analysis part I would be tweaking around. So I think that's it from my side. Anybody has any questions, please feel free to ask, or anybody from my team wants to present their work, please go ahead.
Salman, I have a question.
Yeah.
So when you're trying these blending method, let's take for example,
Blending method, yeah.
You should make sure that your previous results are really good, right? Otherwise, when you're taking that as the input for the next one,
not necessarily. Sometimes even if means I am applying this for the first time, but I have studied it several different times, but I did not see the need of doing that in certain situations. But here I thought, why not? I would just try it and show it to you. Usually, these are the things which are tried in competitions like Kaggle or something. So if you go and check out the winning notebooks, a lot of winning notebooks, they use these methods. So you will never find a simple, straightforward implementation of XGBoost that will win the competition. The stacking blending is what is winning the competition. In 2009, there was a competition from Netflix that you have to beat their recommendation system or something like that. And that's when this stacking was introduced. And the people who won, the team who won, they tried these stacking techniques first time over there. And from that point onward, these blending and stacking techniques have been used in majority of the competition. Majority of the time we heard about XGBoost is doing great, CatBoost is doing great, Light GPM, not on their own. They are usually stacked with something else. Yeah.
Okay, thank you.
Yeah.
Any questions?
Suggestions, please. Any questions?
Salman, did you mention those three, machine learning blog thing post references? Did you mention
Yes,
it somewhere?
I will just post it. It is open in my other. So
also in general as well, like I know most of us going through different useful links, and sometimes we share, sometimes it's good that it would be better to help everyone out. Komal has shared one link. Komal, do you have it handy? If you can share it as well, so at least if you guys can post it over there, so at least we have one comprehensive place.
Yeah, and also the link that Salman is sharing, it is already shared, and it's there in the reference Excel also.
Okay, but I was making some general announcement as well for others.
Yeah, sure. I don't.
This is one blog. Means you don't have to I can keep on sharing these things, but this is one blog. Technically, I stick to this blog because it has everything. And one important thing, anybody who has hands-on machine learning book, if you read chapter number 7, ensemble method, all these techniques have been discussed over there. There are no implementations of these techniques, but you can understand the theory over there as well. So blending is not discussed over there, but the voting and the stacking has been discussed in chapter number 7.
This book,
yeah,
you guys can see it or not.
I think Imran has already shared this book, or somebody, Varun, I think, has shared this book somewhere in, I think, my team. Yeah,
it's shared already in part 1 already. Also, we shared in our project management, as well as in part 2. Varun also shared as well. Yes, twice. And Salman shared that deep learning one as well. Well, that's, I guess, not different. Okay. Any other questions, anyone?
Is there a way to get like feature importance in this thing? Which feature is more important?
Sorry, Roy, I cannot hear you.
So is there a way to get feature importance in this thing? Like which feature is more important?
If you want, yes, I can print out. For example, if I'm implementing the blending technique, just like since my model is linear regression, the second model that I'm using, I can print out the coefficients of the features. Technically, those coefficients are the percentage that I'm assigning to that particular feature, you can say. So if you want, you can figure out that, yes.
Okay.
Okay. Well, before we move on to Roy's side, so from my end, I have been working on some AWS stuff on our data set, and I recently finished one specialization. So I was applying on our data set. There are a few challenges I'm seeing in the Ender part. Although I made these slides as well, but I had a conversation with Salman 2 days ago. I was under the impression that his part will take longer, so I thought it will be more wise for me to keep it for next meeting. So because I wanted to cover all together rather than splitting into two parts. So this is why it's more of a judgmental call than anything else. So that's why I don't think it's wise to cover all the presented PowerPoints are made. So I will not deliberately will keep it for next time. So at least I'll go in one flow altogether. So in the meanwhile, maybe you guys have any questions you guys ask on this particular one, what Salman, our team shared right now. And otherwise, we'll pass it down to Roy's team for now.
There is one thing that I tried, the cat boosting that Salman was talking in the last meeting,
Amazing.
like in our team meeting. I did try it, but I don't know how it worked. I just tried like on our baseline model that you have created.
Mm-hmm.
So with that, I got the RMSE of 0.66 on that on our raw data set. And so that's one thing that I tried, but like I'll be creating the whole like performance Excel sheet on that, and I'll be posting on the channel so that everyone can see.
That's amazing. Do you have anything to show it right now? Because I'm excited.
Yeah, sure, I will. Yeah. I'll just share my screen.
Yes, definitely.
So there are a few changes that I made, like in the our raw data set. What I did was I used like the KNN imputer and the simple imputer, both of them together in just one data set. So I'll show you here with our just a second. So with our direction max wind speed and the peak wind speed, and also with the max wind speed, I used the KNN imputer, and with other I used the normal simple imputer. And in terms of our scaling, I used the power transformer. I just wanted to try. So
definitely, that's good.
Using that, using this data set, I just tried our normal, like the one pipeline that you have created, linear regression, lasso, ridge, elastic net, and also I tried the PLS regression also.
Mm-hmm.
So, and this one, our cat boosting. So this is the result that I got. And in that result, I found that this XGB boost, can you see the screen?
Yes.
So on the XGB boost, random forest, and the cat boosting was the top 3 models. So in this one, XGB boost on our valid data set, XGB boost, I guess I'll just reshare screen again. Yeah. So in this one, you can see the XGB boost was the top performer on our valid data set, and followed by the random forest and the cat boosting. And on our test data set, it was the random forest that came as a top performer, followed by cat boosting and then XGB boost. So this is what I have tried so far.
There's one thing, Varun, cat boost does not need the data to be encoded or something like that. It can deal with the categorical variable on its own. So if you want to remove the encoding or something that you have done in the data and run the cat boost on by dropping, it does not deal with the dropping means missing values. So you need to fix the missing values. But once you fix the missing values, then
Yeah.
don't convert the categorical or encode the categorical query, but just throw it into the cat boost. Cat boost will deal with that automatically. And maybe it can give you different results.
All right. I'll try that too. Yeah, I'll definitely look into that.
Mhm.
Yeah. So this is what I have done so far.
That's amazing.
Thanks, Varun. Good short demonstration. Also, I'm just curious. Well, let Roy speak, present first. Anyone else want to share something here? Well, if not, then I think Roy, you can carry on. Oh, how about we restart, rejoin the meeting?
Oh.
Everyone, please rejoin the meeting.